Hello again, Math 10Cs. In today's lesson, we're going to go through the second half of lesson number 7 on further factoring. The first part of lesson number 7, we looked at what it means to have a perfect square trinomial and how you can factor a perfect square trinomial. In this lesson, we're going to look at some trinomials that are and difference of squares that are in a slightly more difficult format than we're used to from the previous lessons. And it turns out this is going to be the last lesson in the unit. There is a lesson number 8, but it's just review for factoring, which is just going to be optional if you feel like you do need to practice for that. Okay, let's just skip all this text here and just jump down to the type of trinomial we're going to look at. So I'm going to highlight it. So we have a trinomial that looks like x to the power of 4 plus 5x squared plus 6. Now, this is a problem because we can only factor trinomials that are in the form ax squared plus bx plus c. So the issue is you have an x to the power of 4 as your first term, and you have an x squared as your middle term. And what I want to have is I want to have x squared as the first term, and I want to have an x as the middle term. Typically, when you see those high exponents, one of the first things you try to do is factor out a greatest common factor, but it turns out there is no greatest common factor. There's nothing you can pull out that's common between x to the 4, 5x squared, and 6. Now, what I can do, though, is I can rewrite this expression out to get it in my format of an equation that we have up here. So if I take x to the power of 4 plus 5x squared plus 6, I can rewrite it so it looks like, and kind of just bear with me while I do this. We can write down x squared squared. So x squared to the power of 2, you just use the power of a power rule, so that would just be multiplications. That'd be x to the power of 4, and then that'd be plus 5, and then we're going to write down x squared here, and then we're going to write down plus 6. So what I've done is I've taken this trinomial and then I've tried to write it in a format where it actually matches up with the format of the trinomials we've been factoring throughout most of this unit. Now, to do this, we're going to have to make something called a substitution. So here's how this works. So the numbers and the expressions in brackets here, these monomials, like x squared and x squared here, what I'm going to do is I'm going to say, let's pick a different variable to represent that value of x squared. So we'll say let capital A equal x squared. So now what would happen is if I do this substitution and I replace x squared with a, I would then have a squared plus 5, and here the x squared is also a, 5a, and then plus 6. Now, it turns out I can factor this now because this is in the format ax squared plus bx plus c. Instead of using the variable x, we're using capital A as the variable. So we could factor this one through inspection. So what I would need is two numbers that add to give you the middle term and multiply to give you the last term. So that would be 3 and 2. Okay, 3 plus 2 would be equal to 5. And then 3 times 2 would be equal to 6. So if I factor this, this would become a plus 3. And then it would be a plus 2. Now, that's not quite done yet because the value of a is x squared. So what I have to do is after I factor this, I now need to replace a with x squared again. So what this would look like is if you do that replacement, so you substitute back the expression that you start, so you substitute back the value of a with x squared, which is the original substitution that you made, you would then have x squared plus 3, and then x squared plus 2. Okay, let's go through some more examples of how to do this, because I realized that was probably a little bit confusing. So the idea here is we're trying to get our trinomials in the form ax squared plus bx plus c. So this first one, again, we have this issue where we have a to the power of 4 and a squared as my first and middle terms. So I'm going to take this trinomial and rewrite it so it's in this format at the top here. So what that would look like is it would be a squared to the power of 2 minus 5 a squared subtract 14. And the substitution I'm going to make is I'm going to say let capital A be a squared. So in the place of a squared here and a squared there, I'm going to replace it with a capital A. So what that would look like then is then you would have a squared minus 5 times capital A minus 14. So now, as a result of this substitution, we are now in the format of a trinomial that we're familiar with. And now we can factor this one by inspection again. So you need two numbers that add to give -5 and multiply to give -14. So that would be -7 and 2. So -7 plus 2 would be -5. And then -7 times 2 would be -14. So if I factor that, then it would be a minus 7, and then it'd be a plus 2. But you need to replace capital A with little a squared. So in the place of a here, we're going to replace it with a squared. So then this would be a squared minus 7, and then a squared plus 2. Okay, let's look at this next one, b. So again, we have the x to the power of 4, 4x squared, 5. There's nothing we can pull out here, so we're going to rewrite it in this form, ax squared plus bx plus c. So this would look like x squared to the power of 2 plus 4x squared, and then minus 5. And then once again, what we're going to do is we're going to do a substitution. We're going to say let capital A be x squared. So if I do that, I'm going to replace x squared with capital A. And then this would give me a squared plus 4a squared, or sorry, a squared plus 4a minus 5. So I need two numbers that add to give you +4 and multiply to give you -5. That's going to be +5 and -1. So +5 plus -1 would be +4. And then +5 times -1 would be -5. Okay, so if I factor this now, it would then be a plus 5, and then it would be a minus 1. Okay, but after you do this, you have to substitute back for the value of a. So we're going to replace the a with the x squared here. And if I do that, you would then have x squared plus 5, and then x squared minus 1. But we're not quite done yet, because this second factor, the x squared minus 1, this is called the difference of squares. the first term's a perfect square, the second term's a perfect square, and there's a difference between them. So if you want to factor a difference of squares, we did this back in lesson number 5. This would then turn into x squared plus 5. And then to factor the difference of square, x squared minus 1, it would be x minus 1. So you take the square root of the first term, that's going to be the first value in the brackets. And the square of the second term is going to be the second value in the brackets. We'd have x minus 1, and we'd have x plus 1. Okay, now this one, now we have x to the power of 6, and we have an x cubed. So again, I'd first of all start off by checking to see if you can pull out a GCF. You can't, okay? There's nothing common between x to the 6, 9x cubed, and 14. So the first thing I want to do is I want to rewrite it in the format where I'm going to have the first monomial to the power of 2, and then the second one to the power of 1. So if we do that in this situation, so I want to get what to the power, or what squared would be x to the power of 6. It's going to be x cubed squared, okay? Because x cubed squared to be 3 times 2 is going to be 6. And then we'd subtract 9 x cubed plus 14. And the substitution we're going to make here is we're going to say let a be x cubed this time. Okay, so whatever is inside the brackets here is what we're going to make the a substitution for. Okay, so then this would be a squared minus 9a plus 14. And now I need two numbers that are going to add to give you negative 9 and multiply together to give you positive 14. That should be negative 2 and negative 7. So negative 2 plus negative 7 would be negative 9, and negative 2 times negative 7 would be plus 14. Okay, so then this would factor to a minus 2, and it would be a minus 7. But then we need to go back and replace a with x cubed this time, which would give you x cubed minus 2, and then x cubed minus 7. Okay, so this method we're using here to deal with these more complicated trinomials, I might refer to it as substitution. Now, if you don't like this method, there is an alternative method we can use to solve these. So we'll go to the next page and I'll show you how this one works. Okay, so let's just skip all this text here and go down to method 1 and method number 2. Okay, so here's the trinomial I'm starting with. So I have 4 y to the power of 4 minus 11y squared minus 3. So if you take this and rewrite it, we could write it as 4, and then y squared to the power of 2, subtract 11 y squared, and then subtract 3. So the substitution we're going to make here is we're going to replace y squared with a. If you do that, you'd have 4a squared minus 11a minus 3. Now, this one's a bit more difficult to factor because the inspection's probably not going to work here. So we need to use the method of decomposition to factor this one. So the way this one works is through decomposition. You want to first of all multiply a by c. Okay, so the 4 here would be the value of a, and the negative 3 be the value of c. So this would be 4 multiplied by negative 3, which would be negative 12. Okay, now what I need here is to factor this one. I need two numbers that are going to add to give you the middle term. So the middle term is negative 11, and multiply to give you negative 12. So those numbers should be negative 12 and positive 1. So if we write that out, it would be negative 12 plus 1 would be negative 11, and then negative 12 times 1 would give you negative 12. Okay. So now what we do here is the way the decomposition works is you take the middle term, which is negative 11, and then you break it into two parts, where the first part's going to be this number, the negative 12, and the next number is going to be the positive 1. So what this would look like is you would then have 4a squared subtract 12a plus a minus 3. Okay, so I broke negative 11 down into these two numbers I identified, negative 12 and positive 1. And now we can factor by grouping. So I'd look at this first group here. We're going to factor that. And then look at the second group and also factor that one. So that'd be group number 2. So then this would be, you can pull a 4a out of the first group. So you'd have 4a. And then you'd be left with 4a squared divided by 4a would be a. Negative 12a divided by 4a would be negative 3. The second group, the only thing you can pull out is a positive 1. So pull out a plus 1, and then you'd be left with a minus 3. And then you can pull out the common a minus 3. So you'd have a minus 3, and then 4a plus 1. But then we have to go back and do that substitution again. So a is y squared, so then we'd replace this with a, since a is y squared, it'd be y squared minus 3. And then 4y squared plus 1. Okay, and that's my complete factorization. Now, that's one method, so we can call that method substitution. Okay, now there is another method you can use as well. So, and I actually find this one's a little bit quicker. Okay, so we have our trinomial, the same one, 4y to the 4 minus 11y squared minus 3. Now, what I want to do immediately is, instead of doing a substitution, just look at that middle term, which is negative 11y squared, and we're going to immediately just jump to doing decomposition. So jumping to do decomposition would be, without doing any substitution, okay, decomposition would be look at the value of a, look at the value of c, and we go a times c, which is negative 12. And then I want two numbers that are going to add to give me negative 11 and then multiply to give me negative 12. So that's actually negative 12 and positive 1. So what they did here is, without doing the substitution, they actually just broke the middle term, negative 11y squared, into negative 12y squared and positive 1y squared. Now, what we can do now is we can actually just immediately factor by grouping. So if I look at this group here and I factor it, so we'll call that group 1. And we look at this group and we factor it, group number 2. What we can then have is, or the first group, we can pull out a common 4. And for the numerical coefficient, we can also pull out a common y squared. So I can pull a y squared out of that group, and that'll leave me with 4y to the 4 divided by 4y squared would be y squared. The second one would be negative 12y squared divided by negative 4y squared. So that would be minus 3. Out of the second group, you can pull out a positive 1. And then you'd be left with just y squared minus 3. Then we can pull the y squared minus 3 to the front, and you'd have y squared minus 3. And then 4y squared plus 1. Okay, you can see right here, this is much faster. So rather than doing this substitution, you can immediately just start doing the decomposition by breaking the middle term down. And then when you factor by grouping, you're just going to have to pull more out of each group, but it still works out at the end of the day. Okay, so let's apply this method to examples 5 and example 6. Okay, so example 5, we have 4x to the 4 minus 5x squared minus 6. So immediately what I want to do is I want to decompose the middle term. So in this one right here, the value of a, so this would be a, which is 4. And the last term right here, the constant term, is going to be c, which is negative 6. So to use decomposition, we're going to multiply a by c. So a by c would be 4 times negative 6, and that's negative 24. So what I need is two numbers that are going to add to give you negative 5, and then multiply to give you the product a times c. So those numbers would be negative 8 and positive 3. We can confirm that. So it'd be negative 8 plus 3 would be negative 5. And then we'd have negative 8 times 3 would be the product a times c, which is negative 24. Okay, so now what we're going to do is we're going to take the middle term, which is negative 5x squared, and we're going to break it down into the sum of these two numbers, the two numbers we identified. So that would look like 4x to the power of 4. And then, what's the first number we identified? So we're going to write down minus 8x squared, and then plus 3x squared minus 6. So again, what we did here is we took the middle term and we broke it down into the sum of those two numbers. Okay, now we can factor by grouping. So the first group we have here, call that group 1. And the second group we have here, call it group 2. Okay, so if we factor this, out of the first group, I can factor out a common 4, and I can also factor out an x squared. So that would leave me with 4x to the 4 divided by 4x squared would just be x squared. Negative 8x squared divided by 4x squared would be subtract 2. Out of the second group, we can pull out just a common 3. That's it. Okay, so you pull out a common 3, then 3x squared divided by 3 would be x squared. Negative 6 divided by 3 would be negative 2. Okay, then I got the common factors in brackets here, so I can write the binomial in brackets first. Then we'd have x squared minus 2, and then we'd have 4x squared plus 3. And there's nothing more we can do to factor it at this point. Okay, this one, same thing. We have y to the 10 plus 4y to the 5 minus 12. So I want to factor by decomposition. So what I would do here is we need to take a. So the value of a here would just be 1. And then here, the value of c would be negative 12. So a times c would be 1 times negative 12, which is negative 12. And I need two numbers that are going to add to give me positive 4 and multiply to give me negative 12. That should be positive 6 and negative 2. Okay, so this would be, we can check that. So positive 6 plus negative 2 would be positive 4. And then positive 6 times negative 2 would be negative 12. Okay, so we're going to break the middle term down, the positive 4, into the sum of 6 and negative 2. So if I do that, it would then be y to the power of 10 plus 6y to the power of 5 minus 2y to the power of 5 minus 12. And now we just have to factor by grouping. Okay, so here's my first group. Here's my second one, including this negative sign. So you have group 1, and you have group number 2. Okay, out of group 1, we can pull out there's no numerical coefficient that's common except for 1, but you can pull out a y to the power of 5. So I'd have y to the power of 5, then I'd be left with y to the 10 divided by y to the power of 5 would be, when you divide, you subtract the exponents. So this would be y to the power of 5. And then 6y to the 5 divided by y to the 5 would just be plus 6. Out of the second one, there's no variable we can pull out that's constant, but we can pull out a common -2. If I pull out a -2, then -2y to the 5 divided by -2 would be y to the power of 5. And then -12 divided by -2 would be positive 6. Okay, we can bring what's in the brackets to the front, and then we would have y to the power of 5 plus 6, and then y to the power of 5 minus 2. Okay, let's keep going with this one. Okay, so this time around we have a couple of variables. We have both an a and a b. Okay, so it's no problem. Okay, so let's start off with, here's my value of a. Here's my value of c. So let's figure out that product. A times c would be 2 times 99, which would be 198. Okay, so I need two numbers that are going to add to give me -31 and multiply to give me positive 198. Okay, this is a bit tougher to actually determine. Like, it would probably require quite a bit of trial and error to figure it out. But just in the interest of saving time, I'll simply tell you what those two numbers are. So if we take -22 and we add -9, this would be equal to -31. And if we multiply those two together, -2 times -9, it would be positive 198. Okay, so we're going to take this middle term and break it down into the sum of these two numbers. So when we do that, it would then look like 2a squared b squared minus 22ab minus 9ab plus 99. Okay, we're going to go ahead and group these now. So you got my first group here. Call that group number 1. And I got my second group here, which I'll call group number 2. So the first group, I can factor out a common 2. And the variable that's common, I can pull it between a and a squared. I can pull it an a. Between b squared and b, I can pull it a b. So that's my GCF. 2a squared b squared divided by 2ab would just be ab. And then -22ab divided by 2ab would be -11. Out of the second group, there's no variable that's common I can pull out, but I can pull out a common -9. If your group starts with a negative, always pull out a negative. Okay, so -9ab divided by -9 would be positive ab. And then positive 99 divided by -9 would be -11. Okay, move the binomials and brackets, factor those out to move to the front. So you'd have ab minus 11. And then you'd have 2ab minus 9. Okay, so yeah, there's two methods. So like you could have solved A, B, and C using that method of substitution that I showed on the previous page, or you can just simply go to using decomposition immediately, where you just break the middle term down into two numbers, where the two numbers have to add to give you the middle term and multiply to give you the product of A times C. I find this method's a bit quicker, okay, if you don't make the A substitution, but there are going to be situations where we kind of have to do it. Now, this one right here, we don't have to do the substitution. We can still do that method where we just decompose it. So if we look at this trinomial, so this would be the value of A, and the value of C would be -3. So A times C would be 8, multiplied by -3, which would be -24. So I need two numbers that add to give you positive 10 and multiply to give you -24. Those two numbers would be positive 12 and negative 2. Positive 12 and negative 2 would be the middle term, positive 10, and then positive 12 times negative 2 would give you the product A times C, which is negative 24. So we're going to take the middle term, and we're going to break it down into the sum of these two numbers. So that would look like 8 x to the power of 4 plus 12 x squared minus 2x squared, and then subtract 3. Let's form the two groups. We'll call this one group number 1. Here's my second group, which I'll call group number 2. And now let's factor by grouping. Okay, so out of the first group, I can pull out a common 4, and I can pull out a common x squared, which would leave me with 2x squared plus 3. And then out of the second group, I can pull out, well, nothing's common except for there's a negative, so pull that negative out, and then 1 is the other thing that's common. So you pull that out, you'd be left with 2x squared plus 3. Again, I know I've done this correctly when I get the same two binomials in brackets. So I factor those binomials out. You would then get 2x squared plus 3. And then I'd be left with 4x squared minus 1. Now, we're not quite done yet because one of these two binomials can be factored a little bit further. So the one that can be factored is the second binomial. Okay, this can be factored a bit further. And the reason is this is a difference of squares. Which we're going to get into more complicated difference of squares in a moment. Okay, so if you factor that, okay, so nothing happens to the first binomial, it just stays as 2x squared plus 3. Okay, and then this one factors into two factors, where the first term in each factor is the square root of the first term here. So the square root of 4x squared would be 2x. And then the second term in each of these binomials is the square root of the second term, which is 1. So square root of 1 is just going to be 1. And then one of these is going to be minus, and one of them is going to be plus. So you have 2x squared plus 3, 2x minus 1, 2x plus 1. Okay, let's go to the last page, and we'll deal with some more complicated difference of squares problems. Okay, we'll just skip all this text here. What it really shows here, if you read through it, is it just explains that we can use the method of substitution to deal with some more complicated problems that are written in the format of a difference of squares. So the issue with these ones is that we're really only set up to factor a difference of squares if they're in the format ax squared. Well, let's say this. If it's in the format like a squared x squared minus b squared, because then that would turn into, that difference of squares would be ax minus b, and then ax plus b. So the immediate problem here is I have a difference between those two numbers. So as soon as you see just two terms and you see a difference, you should be thinking in your head difference of squares, even though that the first term is the power of 4. But we can write it so it actually is a difference of squares. So I could rewrite this as k squared to the power of 2 subtract 1. Now, what I can do in this situation is I can do a substitution. So what I would do is I would say let capital A be k squared. Okay, so I'm going to rewrite it. So now it's going to look like a squared minus 1. Okay, that's easy to factor because a squared minus 1 is just a difference of squares. So by doing this substitution, I've turned it into a difference of squares. So now this would just be a minus 1 and then a plus 1. But you have to, now that you factored it, you have to replace the a with the k squared. So in the place of a, I'm going to replace with k squared. So then this would turn into k squared minus 1 and then k squared plus 1. Now we're still not quite done yet because this one, k squared minus 1, is also a difference of squares. So if we write this out, then it would be k squared minus 1 is a difference of squares factor to be k minus 1, k plus 1, and then multiply by the other factor, k squared plus 1. Okay, this next one. So again, we see the difference between the two numbers. So you should be thinking like difference of squares, but immediately there's a problem because if it's in the format of difference of squares, then you need to be able to take the square root of the first number and the second number. And the square root of 80 and the square root of 5 do not give you, they're not perfect squares. So once again, one thing you should always do, regardless of which, it doesn't matter which factoring method you're using, you should always attempt to pull out a GCF first. Okay, so pull out GCF. Always try this as a first step. So what's common between 80 and negative 5x to the 4? 5. If I pull out a 5, 80 divided by 5 would be 16. So you have 16, subtract, and then 5x to the 4 divided by 5 would just be x to the power of 4. Now, I want to write it in the format so it actually looks like a difference of squares. So I'm going to rewrite it. So it's going to look like 5 and then 16 minus, we'll say x squared to the power of 2, because x squared to the power of 2 is x to the power of 4. Now we'll do a substitution. So the substitution I'll make is I'm going to say let a be x squared. So we're going to replace this x squared with that a. The substitution just makes it really, really stand out and show you that we're dealing with a difference of squares here. Okay, so then this would be 15, and you have 16 minus, replace x squared with a, so it'd be 16 minus a squared. Okay, let's factor that. So 16 minus a squared is a difference of squares, so we break it into our two factors, where the first number in each factor is the square root of the first number, which is a 4. And then the second term is going to be the square root of the second number. Square root of a squared would just be a. And then minus and plus. But now we have to go back and replace a with x squared. So if I do that, I would then have 5. And then I have 4 minus x squared. And I'd have 4 plus x squared. But again, we're not quite done because one of these factors that I see is also a difference of squares. So this one, which is 4 subtract x squared, that's also a difference of squares. So if we write that out, I'll just do it down here. I'm starting to run out of space. Okay, so this would be 5. And then this one would turn into, okay, so what's my difference of squares? The first term in each bracket is going to be the square root of the first number, which is a 2. The second term is going to be the square root of the second number. So the square root of x squared would just be x. And then you'd have minus and plus. And don't forget about the term we also have on the right hand side outside the red box here. So that'd be 4 plus x squared. Okay, so we have 5, then 2x minus, or 2 minus x, 2 plus x, and 4 plus x squared. Okay, we got one more here. Okay, so this is looking pretty funky. So you've got 2p to the power of 5, q to the power of 4. So I mean, it's immediately weird because like you'd expect the two exponents to at least be the same. Minus 16p t to the power of 4. Now again, always as a first step, you should always attempt to pull out a GCF. And again, you have two terms and you have a difference. You should be thinking difference of squares, but right now it's not going to work because the square root of 2 would be it's not a perfect square, nor is 162. So if we pull out a common GCF here, we'd pull out a common 2. Now, of the p to the 5 and p, the common variable you can pull out is just the variable with the lowest exponent, which is a p. And that's it. You can't pull anything else out because the first term has a q in it and the second term has a t in it. So this would then become, if you pull out 2p, it would become p to the power of 4 minus, or not minus, p to the power of 4, q to the power of 4, subtract 81 t to the power of 4. Now, I'm going to rewrite this out a little bit because I want to write it in a difference of squares format. So if I do this, you'd have 2p. Now, it's a little bit tricky here. So this first part, p to the power of 4, q to the power of 4, I want to write it as something that's going to be to the power of a square. So what that would actually be is p squared, q squared. And then we're going to subtract 81. And I also want to write this to a square. So that would be t squared to the power of 2. Now, I actually have to make two substitutions here. So the substitutions I'm going to make is, first of all, I'm going to replace p squared q squared with, we'll say let a be p squared q squared. And also, I'm going to replace t squared with something else. I'm going to say let b be t squared. So if I rewrite this out now, again, the point of doing this substitution is to make it more clear which format of a polynomial you have in terms of factoring. So if I rewrite this out, this would then look like 2p, and then I'd have in brackets a squared minus 81b squared. So by doing the substitution, it makes it a lot easier to visualize and also to determine what the factors are going to be. Okay, so this would be 2p. This is a difference of squares, so this would break down to two factors. The first term in each factor will be the square root of the first number, or first value, which is a. And then the second term in each factor is the square root of the second term. So the square root of 81b squared would be 9b. Then you have a minus, and then you have a plus. But now that we've factored this, we then have to put these values that we substituted back into the expression. So a we're going to replace with p squared q squared, and b we're going to replace with t squared. So if I do that, this would then give me 2p, and then I would have p squared q squared minus 9t squared, and I'd have p squared q squared plus 9t squared. Now, we're almost done, but not quite, because one of these factors is also a difference of squares, and specifically it's this one right here. Again, you know it's a difference of squares if you look up here, if the first term is a perfect square, the second term is a perfect square, and there's a difference. So what this would factor to is you would get 2p. Okay, and then let's write down the factors here. Okay, so the first term in each of these factors would be the square root of that first term. So the square root of p squared q squared would be pq. And then the second term in these two factors would just be the square root of the second value here. So the square root of 3t squared would be 3t. One of them's minus, one of them's plus. And then we also have to write down this term on the outside here, which is p squared q squared plus 9t squared. Okay, so yeah, this factoring is tougher for sure. I mean, we have to kind of like put everything we know together. So we've had to put together our understanding of pulling out GCFs to factor. We had to use our understanding of grouping. We had to use our understanding of factoring by inspection, by factoring difference of squares, and then factoring using decomposition. So we had to know all 5 of those factoring methods just to deal with these more complicated polynomials that we have, where some of them you can solve using that substitution method, okay, which is, as you can see right here, we use substitution for that. And then some of them you can actually just go to the alternative, which is the decomposition method, which avoids all the substitution. Okay, so here's what we can do in terms of an assignment. So again, I'll just pull it down here because I'm like completely run out of space. All right, so starting on page 368, do numbers. Now you've already done 1 through 3, or hopefully you've already done 1 through 3, but I'll still write down those questions. So do 1 through 7, B, D, F, H, etc. So the new problems today would just be 4, 5, 6, and 7, assuming that you've done 1 through 3 for the perfect square trinomials from last time. And that's it for this unit on factoring. And we'll wrap things up by doing a quiz and a review assignment that is going to help review all the different factoring methods, and then an exam, of course. And then we'll eventually, I think at the end of the week, we'll get into the new unit, which is going to start on, what's the name of the new unit? Relations and functions. So we'll get into that, in the next lecture video, and I'll talk to you then.